So we have two questions here. One of them asking us for the volume that we are going to administer, and the other one for the total volume of reconstituted solution. So first let's look at what we have here. The order, which is always what we say we want. It's what the woman or the patient will need, 150 milligrams. And we are looking for the have, and the have is always going to be that ratio. Remember, we need the two quantities, 250 milligrams in one single ml. So this is our have. There is the label of the drug too, and we'll use that to discover the total volume of reconstituted solution. So first thing we start doing is, let's use the formula method to do the first workings. What we want divided by what we have multiplied by the volume, or that third quantity. So what we want is the 150 milligrams. What we have, we must match milligrams, so it's the 250 milligrams multiplied by that 1 ml. So we see that the milligrams cancel out and our answer comes out in mils. So if we divide 150 by 250 and multiply by 1, we get 0.6 mils. So this is what the patient needs. So this is the volume to be administered. Now let's say if we wanted to use the box method, we draw our box, we look for the ratio. We need the ratio to go in first just because it's good to have two quantities into the box, 250 milligrams in 1 ml. And now we look for the want, which is the 150 milligrams, must sit on the top because we need them to match. We know this is going to reduce. Half of 250 would be 125, so it's a little bit more than a half. But this one we probably need to do a calculation to get the accurate answer. So remember the diagonals. Main diagonal with two numbers, multiply those two, 1 times 150, and divide by the third quantity. In the end, it's the same calculation we have on the left-hand side. It's 150 divided by 250 multiplied by 1, or 1 multiplied by 150 divided by 250. The order of operations here, we usually say it's division and multiplication, but they have no priority. Multiplication or division will come the same way. So that's the answer to the first part of the question, or one of the questions. This is what we do to discover what the volume to be administered should be. Now, let's solve the second part of the question. I'll just move the question down here for us. It's the same piece of information. The only difference now, and I'm going to remove this pink want for us, and move this up a bit more. So what we want this time is the total volume, the full volume. Well, the full volume, we can only discover that if we use the whole contents of the vial. And that's why we have the label here. The whole contents of the vial contains 500 milligrams. The concentration doesn't change. It's the same drug. It's the same concentration because that's how it reconstitutes and what it reconstitutes to. So we use the same idea. We want over half times the third quantity. This time we want the 500 milligrams simply because we want the total volume. So we have to use the total active ingredient in the vial. So want 500, we have the same 250 and multiply by the third number, that 1 ml. The milligrams again go away. We can even do this one in our heads. 500 divided by 250 is 2, and 2 times 1 is 2 mils. So the volume, the total volume of the reconstituted solution is 2 mils. Of course, you could use the box for doing the same thing. If we drew the box, we would start with the have, just because we want the two pieces of information, the same concentration, 250 milligrams in 1 ml. But this time, we want to use the whole contents of the vial to see how much the full volume will be. This one here, we don't even need to do much calculation. We can visually see 250 goes up to 500, which is twice as big. So the volume must be twice as big, 2 mils. Okay? So in this question, we saw that, let's just look at the plain question here again. We saw that we are going to add 1.8 mils to the 500 milligrams, which is the contents of the vial, and that will yield 250 milligrams per mil. But the whole, in concentration, but the whole thing will be what we've just calculated. It will be 500 milligrams in 2 mils, which is the same proportion. You might say, why not 1.8? Because some of these drugs will actually grow or expand a little bit. So 1.8 mils that we add of diluent with the solid ingredient will just grow a bit to the 2 mils. So all you need to always worry about for the calculation is to use the given concentration of the drug.